Hello everyone, Teacher Jonas here, and today I'm going to teach you a new science topic. Now the name is a little long as you can see, but it's a very easy topic. Okay, so the name is Action at a Distance Forces. What does that mean? Let's see, what does action mean? Action means something happening. For example, this boy is running. These girls are throwing the ball. This boy is pulling a box. They are doing an action. Okay? Right now, this is an action. So, action is something happening. Now, what does the at a distance mean? At a distance means no contact. What does that mean? Contact means when you touch, when there is touch of something. For example, look at here. My hands have contact. It means they are touching. But at a distance means they are not touching. So there is no contact. So when I say action at a distance, it means something happening at a distance. Now, what does that mean? I will tell you. Before we do that, let's talk about forces. Forces can be many things. Now, a simple force that you know is push. When you push something, it's a force. Or when you pull something, it's also a force. Look at here. You push the box. It means that this is a push force. And when you pull the box, that means a pull force is happening here. But guys, these are contact forces. Because you see, he is touching the box to push it. Here, he is touching the rope to pull it. So, these are not at a distance forces. At a distance forces means that it is far. There is no contact, but there is force. I know, it sounds like magic, but let me show you. Before we do that, let's talk about what happens when there is force. There is effects of force. For example, force changes the state of motion. For example, my hand is moving this way, and then this hand, boom, hit it this way. So now it goes in a different place because of force. Or my hand is standing here, but then my other hand is like, hey, come here. So I move it. This is also force. Or let's look at here. When there is dough here, let's say slime, you can move the slime and change it. You can make it a round ball. You can make it a star. So you can change the shape with force. Now, force can change the size of a rubber band. You can pull the rubber band. It becomes longer because you are using force. But all of these are contact forces. What about action at a distance force? Okay, let's look at this picture. We have a tree with apples. This is Earth, our planet. This is the ground, and the apple is falling down. Guys, no one is pushing the apple. No one is pulling the apple. The apple is falling onto Earth. Why is that? This is an example of action at a distance force. Now, the name of this force is called, let me show you. Which one do you think it is? Magnetic, electrostatic, or gravitational? Which one do you think? The tree with the apple falling down. It is 1, 2, 3. It is gravitational. Now you're saying, oh teacher, what is gravitational? I will tell you. Gravitational force is the force that is about attraction. For example, you see, all the things on Earth are attracted to Earth. For example, this yellow, when I drop it, where does it go? Does it go to the sky? No, it comes down and it goes to Earth. It comes towards Earth because of gravitational force that Earth has, and it's very strong. As you can see, gravitational force is very cool because it's about attraction. You see, this is attracted to my hand. But it's not only about gravity on Earth that you drop something and it comes down. It's more than that. Look at this picture. For example, the boy is dropping a tennis ball and a basketball together. Boom! They both go towards the Earth. Now, look at Earth. This is Earth. And this is the moon. You see, the moon orbits around the Earth because the moon is attracted to Earth. If Earth didn't have gravitational force, moon would fly away. But because Earth has gravitational force, moon goes around Earth. Now, if Earth had a very strong gravitational force, moon would come and hit Earth. We don't want that to happen. Now guys, gravitational force is very important because look at here. This is the sun. These are all the planets in our solar system. Earth, Mars, and all these other planets orbit around the sun because of gravitational force. Now, if sun's gravitational force was stronger, all these planets would go towards the sun and the sun would eat them all. That sounds scary. So guys, so look at this little experiment. You can do it at home too. When you hang these clips on a piece of, let's say, stick, at first you can see all of them are facing down, which is where Earth is, right? And it is because of Earth's gravitational force making them face down. Now if you tilt it like this one, they will still face down because the Earth is still attracting them. They still want to go down and fall on the ground. Now when you drink water, look at here. Look at the water in this. When I do this, see, it still wants to go down because of gravitational force. So guys, repeat after me. Gravitational force. I know it's a little hard, but one more time. Gravitational force. Gravitational force. Gravitational force. All right, so one more time. Gravitational force. So now you know about gravitational force, but what about the next one? We have more action at a distance forces, guys. Number 2 is electrostatic force. Now electrostatic force is another force that is action at a distance. It means that they don't have to touch each other. There is no need for contact. Look at here. The man rubs the balloon on his hair and the balloon pulls his hair, even if it's not touching. Let me show you what I mean. Electrostatic can be, for example, look at here. Comb attracting pieces of paper. This is a comb. You can rub it on your hair and then you can see that it attracts pieces of paper. It pulls them. That is electrostatic. Now another one is lightning striking Earth. Do you know lightning? Lightning is also electrostatic force, but it's a scary one. Now I'm going to show you a simple experiment that you can do at home. Now I have this very thin plastic glove. Now look what happens when I give it electrostatic force. This is another way. Look. Look what happens. Now it's stuck on my hand. It doesn't fall down because of electrostatic force. It's like grabbing my hand, but after some time it's gonna fall. But if I charge it again, like a battery, like again, it's not gonna fall. And guys, sometimes it works with paper. Look at here. See? The paper moves towards the plastic. Now, if I charge it again, you can see it again. So there are some experiments that I will send you as a video so you can do at home. Now, this was electrostatic force. Next force that we have is magnetic force. Magnetic force. Now, magnetic force is very simple. You already have seen it and you know it. You have to have a magnet for this. This is a magnet. This is a magnet. Now, magnet has two sides. It has north, like this one, and it has south. Now, they both attract whatever metal object or iron that you have towards them. Now, right now, I don't have any iron object around me. No. But look at here. These two are magnets. Look what happens when I bring them close. Whoop. See? They stick to each other. They go to each other. You see? They don't have any contact. It's not pulling it by a rope. It's action happening at a distance. Now, the cool thing about magnets is that they have, as I said, north and south. Now, let me show you. Opposite poles attract. It means that, for example, north and south, they go together, right? But if it's north here and north here, they will go away. See, I will try to put them together, but they will not go. And if I let it go, look, boom, it threw it away because of magnetic force. Magnetic force can be pull and it can also be push, like this. So now you know about action at a distance forces. So we learned about gravitational force. We learned about electrostatic force, and we learned about magnetic force. Now repeat after me. Let me use laser. Yeah. Gravitational. Gravitational. Very good. It's this one. Electrostatic. Electrostatic force. Like a plastic comb attracting or doing this to pieces of paper. You can do this at home with balloon. Next is magnetic. Magnetic. One more time. Magnetic force, which you need a magnet for it. Okay, so look at what's happening to Wiley. What's happening? What type of force is this? Is it gravitational? Is it electrostatic? Or is it magnetic? You are right. It is gravitational force. Good job. You see, the gravity is making him fall down to earth. Now, what about this one? Uh-oh. Boom. So, this is a big magnet. The magnet. Okay, so what type of force is this? This is magnetic force. Great job. Now, what about this? Uh-oh. Look, all these plastics are sticking to the cat. Because something happened to the cat. Maybe the cat laid on something and it made the cat charge. So, it is electrostatic. Very good. This is electrostatic force. Okay, so we have gravitational force. We have electrostatic force, like this one. And we have magnetic force. That's it for today's class. I know today's class was a little hard, but just try to understand each word and what they mean. Okay, guys. Until next time, Teacher Jonas out. Bye bye everyone. See you next time. Bye bye.